Okay, so quick review. Just kind of walk through what to do on the problems. So on number 1, well, first of all, these are as x approaches 0. All of these, all of the limits on 1, 2, and 3. So straight plug in 1 first. You get 0 over 0. Remember, when you see sine, we're looking for sine x over x as x goes to 0. And that's going to be 1. So I can change this to x times 2x minus 1. And then sine x over x is going to go to 1, and then I can plug in 0. Number 2, when I plug in 0, I end up with 4 over 0, which means the limit does not exist because you have vertical asymptote at x equals 0. So again, these are all going to 0. This is going to 0. I found common denominators on this one. I know some people did L'Hopital's rule and did derivative of the top over derivative of the bottom, and that's fine too. 4 and 5, this is 4 is quotient rule, 5 is product rule. 6, remember the derivative natural log. So when I have the natural log of u, when I take the derivative of that, it's u prime over u. So hopefully that will help. Number 7 is product rule here, and then just straight derivative there. Remember, the derivative of e to the u is u prime over, sorry, not u prime over, u prime multiplied by e to the u. So derivative of the power times the original. All right, implicit differentiation. Remember, anytime you take the derivative of y, you have to put dy dx and then solve for dy dx. So I have product rule here, so it'd be x times dy dx plus y times 1, then plus 2 plus dy dx equals 0, and then I'm going to gather up all my dy dx's and factor out the dy dx and solve. Okay. And same thing, product rule for number 9. All right, so this table, so you can kind of think about it like this, and they're giving you, draw this line right here, they're giving you values. So when x is 0, this is the value of my f function, my g function, my derivative of f, and my derivative of g. So when you do 10, 11, and 12, you follow the rules for derivatives and then plug things in. So for example, number 12 is product rule and power rule. So I'm going to do first times derivative of the second plus second times derivative of the first on that one, and then plug in the values and evaluate off the table. 13 and 14, I have to find, if I want equations of tangent lines, I need slope, which is derivative. So I need the derivative evaluated at the point, and then I'm going to use y minus y1 equals m times x minus x1. All right, so for this one, find all constants m and b where the function's continuous and differentiable. First of all, to be differentiable, it has to be continuous. So to be continuous, they have to meet at the x value. So they have to meet when x is pi. So they have to have the same y value, so we set those equal to each other. Plug in pi for x, and you're going to get an expression. Hold that expression. Then you're going to take the derivative of sine x and mx plus b, and then plug in pi for any x's that are left over. And then that should give you information to be able to finish the continuity. So you should have values when you finish for m and b. Sorry, my writing's kind of bad this morning. M and B. All right. 16, 17, and 18. Find the first derivative, set up your table. Find your first derivative, set it equal to 0. Find your critical point, set up your table, and get that information. Increasing, decreasing, max, mins. Then set up your second. Find your second derivative, set it equal to 0. Set up your second table for the second derivative. And then do the point of inflection, concave up or down. I did kick out on 18. I did when I took the derivative, and I get that in the denominator. I did kick it out as I was looking at the at the values. So you'll see what I mean. You're going to have some places where it's undefined, and yeah, anyway, you'll figure it out. You can come ask me if you need help. L'Hopital's rule. So I do the derivative of the top, derivative of the bottom. This one was as x goes to pi. This one is as x goes to 0. I had to do 20 twice. Area between the graphs. So I'm looking area between the graph and the x-axis. I could also ask you a question about the area between two curves, remember? So you can check those out. I did change this problem and I put it on Canvas because that one is not nice. And I got that one straight out of the book. So I changed it. I'm not sure where they were going with that one, to be honest. Let me see what I changed it to. So I changed it to dy dx equals 4x cubed minus 2x plus 1. So you have to integrate this. So dy equals 4x cubed minus 2x plus 1 dx. I integrate both sides. This gives me y over here. Then I integrate that. I get a plus c. Then I plug in the 0.5, negative 3 to find c, and then I can rewrite the entire equation. All right, evaluating the integrals. When it's a definite integral, so 26 is only indefinite without the one without limits on it. But these, put them in your calculator to see where you're trying to go, and then show your work. So 24 is use substitution, 25 is just straight integration, 26 use substitution, 27 use substitution. All right, if you guys have questions, come see me.